Awesome. Yeah. You are welcome to the third webinar for the year, March edition of Precision Feed Academy's Agriculture 4.0 webinar. So, guys, pop in, call your friends, call your family, call your colleagues. Our guest lecturer is here, and trust me, I don't want to let the cat out of the bag. Today is going to be loaded. Yeah, today is going to be loaded. So today we're talking about in Agriculture 4.0, like you know, is we're all what this webinar or this series is all about is introducing you to emerging technology and how they are revolutionizing agriculture, and much more, how can you as a person be a player or an influencer of the fourth agricultural revolution. So we do not just want you to be a passerby or a passerby or an observer, but we want you to actually be a tech inclined, digital savvy farmer in the digital revolution in agriculture. So you're welcome once again. Kendi Ojo, yeah, I see you. Thank you so much for joining. We are live. We are live. So call your friends. Call your friends. Call your friends. We are live. Oh yeah, we are live. So I'm trying to, yeah, I'm just trying to communicate with the community. So we are live. Awesome. Okay, so in 30 minutes, in 30 minutes I will resume back. 30, Okay, thank you so much for the wait, and we'll just say welcome once again to the March edition of Agriculture 4.0 webinar. You are most welcome. And as you're joining us, okay, I can see the population increasing. So as you're joining us, I would like you to introduce yourself, where you're joining us from in the comment section. Yeah, just like you can see the banner moving around below the screen. Uh, please introduce yourself in the comments using the format. For example, Olawale joining from Akure, Nigeria. If you're joining from Ghana, if you're joining from Kenya, Nairobi, if you're joining from um, Zanzibar, wherever, or Casablanca, please, we like to meet you. Thank you so much. So now, without wasting too much time, we're talking about farming in digital age, and how data is transforming agriculture. We have been hearing a lot of things about data. It's the 21st century data, data science, data security, data engineering, a lot of things. A lot of words all around data, data privacy, data this, data that, and how is data or is agriculture left behind? I'll say no. And but trust me, this is just an hypothesis. I believe our lecturer will be demystifying and sharing in more details with us and in a relatable manner. So, how is data transforming agriculture is actually the cruise of the farming in the digital age. So, and before I go further, one more thing I like you to know is that the purpose of this webinar it's is so that you can be enlightened, so that you can be up to speed with what is happening in the world as regards agriculture, and not just have the knowledge, but to spur you into taking action. Into taking action. So um, and being, like I always say, being a player or an influencer in the 21st century, talking about for smart farming, precision farming, digital farming, all of these matter, and they are all referring to the fourth agricultural revolution. So now, let me now introduce you to um, Precision Feed Academy before we go into the lecture info. All right. So, um, Precision Feed Academy is actually an organization who is actually organizing this. And what is it about us at Precision Feed Academy? What is it about us at Precision Feed Academy? So our vision is to create a world where every young person, regardless of your background, has the opportunity to become a digital savvy farmer or agricultural professional, driving sustainable and equitable growth in communities through transformative power of technology. So, in short, we believe that wherever you are, where you're coming from, you have the opportunity of becoming a digital savvy professional in the field of agriculture, and you are actually causing sustainable development and equitable growth in your community and leveraging on the power of technology. So we are going to be talking about technology, and that's what we are known for: technology, digital technology. And our mission is to actually raise the next generation of farmers that are tech inclined and digital savvy. So the next generation, and this is actually you becoming a farmer, becoming a professional that is tech inclined and digital savvy. All right, so we are a social enterprise. We are dedicated to training and educating the next generation of farmers on emerging technologies in agriculture, be it drone technology, um, artificial intelligence, robotics, GIS, and remote sensing, and all of these emerging technologies that are vital or they come together to aid us achieving precision agriculture and other names which we call them digital agriculture, smart agriculture, farming, and also to equip you um, for the future of work and technology in agriculture. So enough of us just seeing technology from afar, but we are now living in a world where artificial intelligence and all that sort of digital technology surrounds us. The question is, what are you going to do with these technologies? How are you going to leverage them for your growth? How are you going to leverage them to actually create sustainable impact in your community, in your society, in your nation, and most importantly, globally? And what will be the result of that? Food security. What will be the result of that? Building a career that is actually decent and noble. You can be able to create a legacy for yourself. You can be able to do something amazing that you are proud of. You can be able to find fulfillment, being equipped to use technologies around you to drive your mission or your goal. Now, so yeah, I've said that we are a social enterprise. We train and build the capacity of young professionals in modern and emerging technologies for the future of work and for you to actually lead with precision agriculture. Now, how do we deliver on this? How do we deliver on this? Our promise. Number one is we have these three cardinal methodology or methods. One is education and knowledge sharing. So, what do we mean by education and knowledge sharing? Example of that is what we are doing presently. We are here to actually share with you knowledge. We are here to actually share, educate you about how, for this edition, we're educating you about farming in the digital age, in the 21st century, and how data is actually transforming agriculture. So this is actually what we are doing. We are creating various platforms to educate you. We have a community where we share knowledge and idea. And if you are in our community, you are not asking questions, you are not engaging, you are actually not maximizing the opportunity you have. It is there for you to engage with community, not only for us to share. You lead us, you guide us. I mean, suggesting to us what you want to learn and being active. Don't be passive. You need to be active. Now, the second method is training and skill development. So, what do we mean by this? We believe that when we are able to train critical mass of people, we can be able to change the landscape. We can be able to move things forward. So training means that we are actually training you to actually develop the skills you need, the skill set you need. It comes to training, capacity building. It comes to training, building your capacity. You are actually a major farmer. How do you want to scale? So we are actually bringing this training and skill development to you. And number three, which is very, very important, is coaching and mentorship. Yeah, coaching and mentorship. This is what we are doing. I, as a person, I am actually prone to coaching and mentorship and helping you to navigate the murky water in technology and agriculture. We are all learning, fine. And it's because we are all learning. That is why we can be able to share, we can be able to guide you and those who are born, and much more. Our lecture today, we bring industry leaders to you. Yeah, our industry leaders, you can be able to listen to them. You can be able to be in contact with them. You can be able to have close, perhaps a closer relationship if that is allowed. And also you can be able to learn from them, their thoughts pattern, their process, what they have done, their advice. This is what we are doing here. We are bringing top professionals, and you know that from the beginning of the year, people that we are bringing, so they are actually pioneers, leaders in the field of digital agriculture, precision agriculture, smart agriculture, whatever acronym you want to give it, or name you want to, nomenclature you want to give it. So this is why coaching, and we want to actually shorten the lifespan, lifespan. I mean, the time for you to be able to learn, become relevant. But with coaching and mentorship, we can shorten it. We can, instead of you rambling around, you can shorten it. This is actually the cruise of this method. So three methods in this methodology: education and knowledge sharing, training and skill development, and coaching and mentorship. This is very, very important. They are very important. And now, what are the test skills that or the skills that we are promoting? Drone technology is actually one of them. Yes, drone technology. Of course, this is the flying farmer, and I use drone technology in agriculture. And most importantly, geographic information systems and remote sensing, or GIS and remote sensing. We are also training and building capacity on data science for agriculture, and also robotics and the Internet of Things, and also artificial intelligence and machine learning. And lastly, bringing all of this together to be able to create impact is enterprise development. So, all right. Let me quickly move fast so that we can get into the work of today. So what's our motivation? Why do we do what we do? We know, we've discovered that there's a skill gap to be closed. Yeah, young professionals like you need to build capacity, or need to build skills, technical or enterprise skill, for the future of work in agriculture. The second is we have actually observed the trend. I mean, just observing the trend is not enough. Yeah, you just watching and seeing, oh, how is it going? Okay, now you're talking about chat GPT, observing the trend is not enough. We want to bring you into the trend, not just observing the trend. Youth needs to become enablers and players in the fourth agricultural revolution, and not just mere observers. And lastly, technology is key to unlock African agricultural potential. Technology is very, very important, and that's because it's a leveler, it's a leverage. If we want to actually get more with less, we cannot but talk about technology. So why you should join us? We are creating the future we want in agriculture. Like I do say, the best way to predict the future is to create it. So we connect you to the information and the world of opportunities in terms of scholarship. This is actually what you gain when you come to our community: scholarship, internship, volunteership, and a lot more capacity building or that can actually help your career, local and international, for your growth. Skill development through project collaboration, community interaction, and workshops. Yes, a lot of this is coming. And also access to coaching and mentorship from industry leaders and professionals. So we are Precision Feed Academy. You can call us PFE Academy. We are building a community of young, tech inclined, and digital savvy farmers and professionals. So you're welcome once again. And without wasting much of our time, we are talking today. I can see. Thanks so much for joining us and introducing yourself. So today we are talking on farming in the digital age, how data is transforming agriculture. Now, just to introduce my speaker, introducing my speaker. Thank you so much for joining. Introducing my speaker. Yeah, you're welcome, Dr. Joseph. I will bring him on the screen right now. Yes. So you're welcome, Dr. Joseph. And that's Dr. Joseph.
Thank you very much.
Yeah. So I will just read your profile so that we can be able to conceptualize or appreciate um, your expertise. So I present to you Dr. Joseph Mhango. He is actually an agricultural scientist with expertise in the integration of remote sensing and data science to solve agricultural production problems. His current research interests and area of active engagement include plant growth analysis and yield prediction using remote sensing, automation of automation of perception tasks in agriculture using computer vision and deep learning. And these are the buzzword now: artificial intelligence. Democratization of graded data sets by developing public interface to geospatial data using the website there. That's Melangis, yes, melangizi.org. You can actually copy that on your browser. You will be able to see the wonderful work that he's doing there. I mean, geospatial, you would see, and he's going to be sharing more on that in this webinar. He's also focused on digital phenotyping using visual and hyperspectral imagery. I know this very well. And just to also let you know that I met Dr. Joseph in the UK while I was studying with him in the same university. I was studying master's degree, and he was studying for his postgraduate and doctoral degree. So I actually learned his research actually inspired me. Yeah, his research actually changed my trajectory. I mean, it's contributed. I must confess to you. Yeah, and I think you know that. So it
Thank
actually
you.
yeah, and particularly about phenotyping. So developing of the next one is development of mechanistic growth, crop growth simulation model. With okay, sorry about the break. Uh, so with a background that includes agronomy, soil science, and applied remote sensing and data science, Dr. Mhango has extensive research and commercial product development experience in both African smallholder mixed farming systems and large-scale commercial monocropping system in the global north. So join me, welcome Dr. Joseph Mhango. Thank you so much. He's an applied remote sensing and agri-informatics specialist. You're welcome, sir.
Thank you very much, Femi. Thank you. Shall I share my screen and start my
Yes,
presentation?
yes, please.
All right. Thank you.
Guys, as a speech, please pop in your questions. Okay. Here you go, sir. So pop in your questions. Please engage in the comment box there. I would be, yeah, please drop your questions, your comments. We want this to be engaging. And trust me, I will pick every one of them, if need be, even during it. But there's a time for question and answer after this. So, Dr. Joseph, over to you, sir.
All right. Thank you very much for the nice introduction for me. Very happy to be here to talk about big data in agriculture. There's a lot to talk about, so if I'm going too fast, be free to stop me and ask a question. I know there's question time at the end. We might as well do it that way. But either way is all right. I'm very excited to be here. Femi has already introduced me, my background, soil science, agronomy. I've worked with smallholder farmers in Africa for quite a long time, with IITA for a long time as well in Malawi. Now I work with more commercial farmers in the UK, but uh, I do have a big eye for smallholder farming in Africa still, and hence the platform that's called mlangizi.org. So, what are we going to talk about today? My presentation is mainly 4 points. First, why is there so much hype about data? And secondly, who is using big data and how in Africa in the context of agriculture? Uh, Thirdly, what's missing? Is there a gap in this field? Where does it occur? And the last one is, where do I start? So that's a question that everybody perhaps ask themselves. If I want to be part of this big data evolution or revolution, if we may call it, where do I start? So that's basically what I'm going to talk about. There'll be lots of slides, but these are the main anchoring points. So, why the hype about data? Well, the hype about data in agriculture is really attached to the sustainable development goals and what we want to do as the human race for the world with a view towards 2050. So there is this, for those of you who are in the conversations of agriculture research, you will know that sustainable intensification is another buzzword. Uh, we want to increase productivity on existing agricultural land in the world using any innovations that are there. And the primary reason why that is important is that by 2050, we'll be around 10 billion people in the world. And to feed those people, we need to increase our food production by at least 56%, as you can see on the right. But at the same time, we need to do that without expanding the area that we allocate to agriculture. Because agriculture is giving a lot of pressure on some of the world's most important resources, rainforest resources. It's giving a lot of pressure in the habitats of wildlife. It's contributing a lot to greenhouse emissions, greenhouse gas emissions. So we need to increase, we need to feed a growing population in the world without actually increasing the area that agriculture takes up. That means we need to produce more on existing agricultural land. And to produce more on the land that we already farm right now, we need innovations. And those innovations will depend on us as a people in the world having an advanced knowledge about the crops that we grow, how they grow, so that we can make the right decisions. How much fertilizer should we put? How should we control pests and diseases? Where and what time should we apply pesticides? Which fertilizers should we use? What do we know about our soils? What do we know about how our crops grow, so that we know when to apply fertilizer and how much? So we need a lot of information about our crops now more than ever if we are ever to increase yields uh, without increasing the land that is allocated to agriculture. Um, this graph just buttresses the point that I made. So by 2050, year on year, as you can see, these are the uh, annual growth in yield per hectare that we need to achieve in order to avoid increasing land. And you will see that we need to raise uh, the yield of roots and tubers by a substantial margin because most of the population increase is actually occurring in areas that consume roots and tubers a lot. So we do need to produce more of these crops. Year on year, we need to increase the yield of these crops until 2050 in order to avoid having to expand and pressurize land resources that we do not want to as a human race. So we have a big task, and that big task will not be achievable without data. And that is why everywhere we go, there is a lot of talk about big data. We're collecting this data, we're collecting that data, we're building this data security system, we're building this data dashboard, because everybody realizes that people need more information. It's no longer enough to just plant, apply a little bit of fertilizer if you have it, and forget about it. You're not going to yield enough, and you will remain a smallholder, subsistent farmer. You need a lot more information and how to use that information to produce more crops to feed a growing population. So that is the hype about data. It has nothing to do with people just being excited with technology. It really is a very important part of agriculture that will determine whether or not um, we have enough food to feed ourselves by 2050. So that is the reason why there is that hype. So underpinning this hype is a lot of things that are currently available. People are producing yield maps that exactly tell you how your crop performed. People have yield sensors, especially in countries where people are using combine harvesters. Soil maps are being generated as well at a field level using some geostatistics. We'll talk a little bit more about that in a few slides. There's high resolution satellite data. There is a lot of drone imagery being collected, and it's becoming popular as well in African contexts. Things like electrical conductivity is being collected in soils to classify soils in terms of water holding capacity. So people are moving away from going to the field, collecting one or two samples and analyzing its water holding capacity and saying this field has a water holding capacity of X. They're now doing high resolution electrical conductivity so that you can classify where your field holds water better than other areas of the field. And then you do precision irrigation based on water holding capacity. And all of that comes from a measurement of electrical conductivity of the soil. So there is a lot of data being generated, especially in the global north, the developed world. Uh, and there is a lot of growth that should happen in also the global south, in sub-Saharan Africa especially, for us to understand our cropping systems better and make better decisions if we want to harvest a bumper yield. So all this data sounds sometimes very technical, and you can't really, it's very difficult for somebody, especially who is just beginning or somebody who doesn't come from an agricultural background, to really connect why all this data and all these gadgets being used to collect data, why are they relevant? What are we trying to see? Why electrical conductivity? Why drone imagery? Is this just fancy things to use on our fields? Do they actually help? They do. For those who may or may not come from an agricultural background, we grow plants because we want to have a yield that we can sell or eat in our house. And that yield has a very simple sounding equation for it to formulate. Yield in agriculture is a function of how much sunlight the plants have intercepted, how they're using that light that they have intercepted. So for every intercepted, for all this sunlight that a plant intercepts, not all of it is used in photosynthesis. Some of it is converted into heat energy and let go. That's why if you use an infrared camera on a drone, you are able to do thermal imaging because you're picking out whatever heat energy the plant is letting go. So there is an element of light use efficiency. Some of that light is let go. Just like any electric bulb. You give an electric bulb electricity, it doesn't use all of it. It converts some of it into heat energy. So plants are the same. They have a certain light use efficiency, and that determines how much carbohydrate they can produce. And also, once they produce that carbohydrate, then they have to turn it into either leaves, roots, or seeds. So there is that concept of a percentage that's going into your grain or your tubers or your roots if it's cassava. And that's what makes up yield. So the plant intercepts light. Some of that light is turned into carbohydrates. Some of those carbohydrates are turned into seeds, while some are turned into leaves. And you want to maximize the light use efficiency. You want to maximize the percentage that's going into the seeds. You also want to maximize the sunlight that the crop intercepts. There is this famous saying by a chap named Eric Allen. He's a legend of potato production. He said, knowing how potatoes grow determines how to grow potatoes. I brought up this slide because I wanted us to keep that in mind as we're discussing data. We need to combine all this technology that is collecting all fancy information to the fundamentals of how a plant grows. Because if you know how a plant grows, you know which data will help you assess how a plant grows and make the right decisions. So we need data to understand and control those three things. The first one is intercepted radiation. So how do you assess it? You can assess intercepted radiation by counting the number of plants in your field. If you have many plants, they'll cover the whole field, and you know I have enough plants here to intercept all the radiation. Whatever sunlight hits this field, I am intercepting it. I'm not allowing anything to touch the ground. That's the ideal scenario. Obviously, you can't do that all the time. So you have to be able to have a system that allows you to assess the percentage ground cover. How much of the ground have I covered? If I can put a drone in the air, assess how much ground I have covered. If I've only covered 20%, I know I'm doing poorly. If I've covered 80%, I know I'm doing well. If I've covered 100%, I'm doing exceptionally well. So that means ground cover and anything that can assess ground cover is a very important data system. So if a drone can do it, that's good. If a satellite can do it, that's good. If it can collect leaf area index, which is another measure of the apparatus that is available to intercept light, that's also a good thing. Let's move on to the use efficiency, this radiation use efficiency, or what I call light use efficiency. It depends on plant nutrition. So we know that plants intercept sunlight and absorb it using chlorophyll. And chlorophyll splits water to gain an electron. For those of us who have an agricultural background, we know that. So if we have a system that allows us to determine the things that affect chlorophyll production, we also have a very good system that allows us to track how well the plant will do. So plant nutrition, anything that tells us how our soil is, because we know that chlorophyll contains nitrogen, contains magnesium, And all those NPKs that we have in fertilizer, they assist chlorophyll. So any data system that allows us to assess how well our soil is very important. Any data system that allows us to evaluate our water availability is very important for us to determine how our crops are doing. The concept of harvest index is the third one, which I explained before to be the percentage of the carbohydrates that we've produced that actually go to the seed. And this depends on many things. And one of those things is the growing degree days. So if you plant late and you haven't given your maize, if you're growing maize, enough time to mature, and it hasn't gathered enough heat energy within it, using enough radiation within it to begin flowering at the right stage when it has a full set of leaves, and then start putting enough energy, enough carbohydrates into its seed, you're not going to yield well. So anything that allows you to measure growing degree days, like any system that measures temperature, is good. So if you have a weather forecast, that's a very good thing. If you have satellites that allow you to determine the temperature and how it has progressed throughout your season, that's also a good thing. So I brought this up. It sounds very technical and agricultural, but I brought this up because it is very important for anybody going into data to understand that there is big data and then there is good data. And you need good data to make decisions that actually give you a profit as a farmer. And to know which data is good, you have to understand how a plant grows. So I wanted to bring this up before I go into which are the people that are using data to make actual good decisions. So who has a head start? Who's already doing big data stuff, and how are they doing it? We know there is a lot of applications that say they use big data, but who are some of the most prominent ones? So I made up a few examples just to share with you, some big companies all the way to some smaller stuff that I have personally been involved in. I want to bring this up in order to let you know how people are using this term big data in actual practical situations that make a difference at a country level, regional level, farm level. The first one at a continental level, the first one that I wanted to bring up is FuseNet. FuseNet is the Famine Early Warning Systems Network. It was set up by the US government. This network combines countrywide production estimates, crop production estimates. They combine that with remote sensing of vegetation growth. They combine that with temperature monitoring over time. They combine that with disaster monitoring over time, data from all different sources. They put it together in order to be able to say, to be able to predict whether there will be a famine or not in any specific place in the world. And this is a very big program, and it is used practically by governments to decide which areas will be hungry in their country, where they need to send humanitarian aid. And this is a very good big example of proper big data usage. When I say countrywide crop production estimates, I mean you are taking in my country, we have this thing called agriculture production estimates. The extension agents that we have in our areas they do yield surveys. It's very dirty, very unclean data that needs a lot of cleaning, but they estimate the area that has been allocated to soybean, to cassava, to maize, to everything that's important in that area. And they do it all over the country. Many ministries of agriculture in many countries support this. So every year they have this big data set of where people are growing which crops in the country. And using that information, FuseNet will combine it with remote sensing data, and they will track things like how NDVI is developing in a specific area. So they will start tracking NDVI for, I don't know, Ibadan, and how it's developing throughout the rainy season for Ibadan, or whatever, however seasons go in Ibadan, Nigeria. And based on that, they are going to be able to track, as they're also tracking temperature, if you remember, as I said. They're going to be able to combine all this information and say, based on how we know cassava to grow, based on how we know soybean to grow, and how this area has done so far, and the area that has been allocated to cassava in this area, we are going to have a cassava problem in this area. And they're able to tell governments way in advance to say, based on this big data analytics, there's going to be hunger in this area, and you need to support people with humanitarian aid. So governments can know 2-3 months in advance that there's going to be a lot of hunger, and they can plan how to get humanitarian aid to those areas. So this is one practical example. If you look up FuseNet as a website, you can go. It's an incredible resource of how disaster tracking, especially with regards to famine, is supposed to be done. And I think it's an awesome website. If you inclined to it, please do visit it and learn more. The second example I wanted to give is open soil nutrient data. We know one of the most difficult things to tell our farmers to do is to get themselves a soil sample and send it off to a lab and know how much nitrogen they have so that they can decide the fertilizer they have. It's very difficult. There are two organizations. One of them is the World Soil Resources Institute. It's based in Wageningen in Holland. And the other one is ISDA. It's a smaller company, but it came out of a bigger initiative called the African Soil Information Service. They have produced digital soil maps for all of sub-Saharan Africa at a very high resolution. And their data is open. It's free. It's there for anybody to use. They took so many soil samples and did some fancy geostatistics and produced data for every single country in sub-Saharan Africa on how soils, the soil nutrition in all our soils. So it's not just nitrogen, phosphorus, potassium. They have organic carbon. They have pH. They have soil texture, soil, sand, clay, percentages. This is a very rich data set that is available both from the World Soil Resources Institute and from ISDA. It's open data. It's just this week, actually, I was seeing ISDA has released this even on AWS. It's available for you to download even as an Excel document, as a CSV, so that you can use it to know how your soils are in your area. Surprisingly, this is not data that most people are using, but it's out there. And they're developing agronomy applications based on this. They have an agronomy app to advise farmers on nutrient amendment and management. The third example that I wanted to bring up is the website that Femi introduced before. It's called Mlangizi. Mlangizi is a Malawian word for extension agent. It's essentially a dashboard that I put up together. What you see on your right is a video of me just scrolling through the dashboard. It's a dashboard that brings together different data from different sources. So on this dashboard, I've brought together all the soil data from the World Soil Resources Institute. I'm tracking things like evapotranspiration from NASA. NASA have also a data set that they update every single week on how evapotranspiration varies across the entire globe. No place is left unturned. Precipitation, how rain has fallen in our places, temperature, total radiation, diffuse radiation, soil wetness. There is a lot of data here. And I've put together this dashboard that anybody can go from Malawi or anywhere in the world can go choose a specific date and look around the country to see, for example, how rainfall varied on that specific date. And when you look at that data, it actually is quite accurate in terms of how rainfall varies in that specific country. So this is an example of a way that you can bring together gridded data sets into one place. Because like I said, there is NASA, there is Wild Soil Resources Institute, there is ISDA, there is FuseNet, there is satellite data. Data is too fragmented in different places and different silos. So there is need for somebody to bring all this data together in a convenient place that people in agriculture can access it and use it. And this mlangizi.org is just me scratching the surface, but there's a lot of data here. There's prices data, how prices vary in different markets, so that you can make decisions where you want to sell your crops. The World Food Program tracks prices. Unfortunately, they release them as a CSV file on a very obscure website. And as a data person, you have to find that and bring it out. That's what democratization is. You have to find these data that are existing in silos, bring it together, and make it usable for others. So this is one of those efforts. And we're hoping going forward that we will link them up to mechanistic crop models so that from this data, anybody can go to the website, put a GPS of their farm, tell us when they planted, and then we can tell them, based on how temperature has developed, based on how rainfall has come, we can be able to advise them to say, if you want to harvest, harvest on X date, or you have a problem here, consider irrigation, things like that. So this is simply the beginning for that platform, but it's something we're going to grow into a decision support system. At a field level, we have a lot of farmer-centered applications that people don't know that they are doing a lot of data science underground. So there are things like the Akilimo application that was developed, I believe, by IITA, if I'm not mistaken. It's available in Nigeria and I think Tanzania. They're using their expertise in agronomy and they're combining that with some of the same data sets that I've just shown you. But it's all happening behind the scenes. How they're presenting this is they're presenting it as an application to a farmer or as an SMS application that a farmer can send a message to and get some recommendations about what to do in their field. But what's happening underneath is not just a lookup table to say if the farmer is located in Ibadan, please recommend X fertilizer. No. There's a lot of data science that's going on underneath, a whole data system. But because data is very technical, the product that you produce doesn't have to look like the data that has produced it. You have to produce data products that essentially analyze your data, bring insights that are relevant to a farmer so that a farmer does not need to know about the World Soil Resources Institute. They just need to know how much fertilizer they should apply in their field. And that's what some of the field level applications are doing. So I have brought, if you've followed well, I've brought this journey down from a global level application like FuseNet that is used by governments to decide where to take humanitarian aid to a sort of country level application like mlangizi.com that you can use to decide how precipitation is varying over time in your country that can help you decide, oh, I want to buy land. Where should I buy? You go to mlangizi.com, look at it and say, oh, this area always has low rainfall. I'm not going to buy land there. I'm going to buy somewhere else. That's a regional application that allows you to do that. And then there is this type, a field level application that allows you to make decisions to say, when should I harvest? When should I apply fertilizer? So all of these, what underpins them mostly are the same data sets analyzed differently by different data scientists and augmented by other bespoke data. So the buzzword data here drives government level decisions at a global level, regional decisions that can be made by you and me as people, to field level decisions that can be made by a smallholder farmer. Everything revolves around data. That's what we need to take away here. So the hype about data is not a hype. It is what will underpin which countries, which people, which individual farmers survive. If you use your data well, you are going to do well. If you use your data badly, you're not going to do well. It's as simple as that. So I think as a motivation, that really is good. But what's missing? The things that are missing, the things that people are working on right now in data is, number one, better satellites. Most of these products are based on satellite imagery and satellite reflectance data. We need better satellites. We need more satellites that are not affected by cloud cover, because every time you have clouds in the sky, most of the optical satellites can't give you any data. So there is a drive to have radar satellites collect data for us more. We need to look beyond satellites. We need to start using aircraft and drones. This is where people like the flying farmer are very important, because you can operate any day, any weather. But we need to democratize drones. So more people need to know how to fly drones and have the authority to fly them and have the skills to submit the results of their flights to some sort of central location that can analyze that data and tell them what to do and what not to do. So drones will play a very important role in getting rid of some of the inconveniences of using satellites. We also need better predictive analytics. So we collect a lot of data, but not many people know what to do with it. So many people have access to data, but so many people produce really bad models. And that's one of the reasons why it's very hard to break into data science as a business, because not many people know how to produce a really good model that makes physiological sense. And this is why in the beginning I talked about the importance of having knowledge of how plants grow. We also need innovators, so people who can produce profitable use cases for the available data. So very good data science people, very good data cleaning, very good modeling, things like that. That's what we need. So what are some of the examples of innovations? I'll bring back what we talked about before. We need systems that can do intercepted radiation, systems that can do radiation use efficiency, systems that can do harvest indices. Satellites can do ground cover, so can drones. Satellites can do leaf area index, so can drones. Satellites can't do plant density, drones can do. Satellites can do plant nutrition by using proxies like NDVI. Drones can do that too. Soil sensors can collect drone data. Soil data. Soil sensors can collect water availability data, or so can satellites. So you can see most of the tools that we have can collect this data, but it is noisy, and you need innovators that will turn this raw, noisy data into products. And what you see on the right is an example of a product that I've been involved in developing. We are predicting potato ground cover from satellite imagery. We're not even using the optical data to see how green it is. We're just using radar data, the radar reflectance data, because it's not affected by cloud cover. And using that, we produce a map like what you see on the right on top for every farmer that is part of the business that I work with. And on the bottom is what we show the farmer as well. We show them based on when they planted their potatoes. We show them the benchmark, how a potato is supposed to develop in terms of ground cover. It's supposed to start rising really fast and reach 100% ground cover, stay there for about 8 weeks or so, and then come down really fast. And then we tell them what our satellite prediction is telling us their field is doing. And that is the blue line. So based on what we tell them, we are able to tell them that, well, your field was developing rather slowly. And because of that, you couldn't even reach 100% ground cover. And then your field dried up really late. Perhaps you've been over irrigating at the end of the season, so your field is not drying. Perhaps early on, you had a problem with your plant densities. That's why you didn't cover your ground very quickly. And using that information, the farmer is able to tell how much they're going to harvest. We plug this into a mechanistic crop model that tells the farmer how much they're going to harvest well before harvest. And they're able to use that information to make decisions, because if you're growing your potatoes for KFC, you want them to be really large because people like large chips. So you want your potatoes to reach ground cover very quickly so that they can focus all their energy into putting more starch into tubers. And farmers find this very valuable. This is an example of practical use of remote sensing, very freely available radar data from satellite to produce something that a farmer uses commercially and make money out of it. So these are the sort of things I believe we need. The second one that I wanted to bring about is counting potato plants. Well, I've talked about potatoes a lot because I work with potatoes quite a lot. Can we count potato plants in a canopy that looks like this? It sounds very difficult. How do you even begin? Why do we even want to count potato plants? And when I say plants, sorry, I should say stems, because potatoes, you plant one potato, but it produces multiple stems. So you can't even just estimate how many potatoes you planted. It doesn't tell you anything, because multiple stems will be produced from that. And each of those is an independent plant unit at some point. So then how do you count how many plants you have? Because if you know how many potato stems you have in your field, you can know how many tubers you have. It's a very good indicator. That's what the graph on the left shows. We use the drone to do that. This is a practical use of a drone. We use a drone when develop a deep learning model, a convolutional neural network, that when we feed it a new image of potatoes from above, it picks out all the stems, and it does so accurately. And from that, we're able to give a farmer a map to say, in your field, this is how potato stems vary. In that area, many stems did not form because it was waterlogged. In this area, many stems formed because it's very good soil. And the farmer can make decisions on how their field performs in terms of potato stems. So that's a second innovation. The third innovation that I wanted to bring as an example is, how do we get more farmers to grade yield samples? This is also something that I've been involved in developing. Most farmers want to know everybody here wants to know when they're buying potatoes that all the potatoes will be the same size. It's one of the things that determines the price of potatoes. If somebody sells you potatoes and most of them are really, really small and a few are large, you don't want to pay that much. But most farmers don't, they have means to control their production to make sure that sizes of their potatoes are similar. But the most difficult thing is knowing how big your potatoes are, because you have to go and dig them, look at them, and then maybe if you are a data-centric farmer, you have to start measuring how wide and how long each potato is to get a sense of, on average, my potatoes are 50 millimeters wide. So this is a good market size. Farmers, especially in the global north, want to know exactly what their width is, because that determines the contract price. If you're selling to a cheap shop, they want large potatoes. But they don't want to be measuring individual potatoes. So what do? We use data. We tell them to collect images for us, and we produce a deep learning model that when they dig their potatoes while they're still in the field, just lay them down on the ground and take a video. From that video, we are going to detect all your potatoes, and then we're going to size them, weigh them digitally. You never need to grade your potatoes again. You are going to have your potatoes weighed, measured, sized, every single potato digitally. Just do it via video. And it's a solution. Most farmers will just take a video with their cell phone and submit to an application. And that application goes ahead and produces a three-dimensional model of the potatoes. And from that three-dimensional model of the potatoes, we tell them how wide their potatoes are. Farmers don't even have to see all of this. All they know is, oh, I submit a video to this application and it gives me all my potatoes, how wide they are. But what's going on underneath is a lot of data science. You're doing deep learning to detect the potatoes, and then you're producing a three-dimensional model, and you're slapping your deep learning model there and produce results. So that's a practical use of data science to solve actual problems. It's not. That's why I liked one of the comments in the chat. Also, I'd say data science is not hype. There are very good, very profitable use cases, but not many people realize that. And this is one of those use cases, because this is a commercial product that is going to be offered to farmers, for example, in the UK this year. And this is one of the projects that I've been involved in. So those are the practical innovations. I gave all this. I know that hopefully it will inspire somebody to look at data science as not something you do because it's hypey or something you do because that's where the industry is going, but you don't have a clear idea. There are solutions and there are people to talk to. If you wish to be guided, reach out to people like me and we will guide you where to get started. Where do I start if I want to start? The statement that you should go by is this statement that says data is the new oil. If you are a social media influencer, you will see social media influencers saying content is king. It doesn't matter how good you are as a data scientist, what you need is the data. That's the first thing you need. You need very good data. Because modeling, as fancy as it is, will be automated very soon. There are also already a lot of auto machine learning systems from Google and Microsoft. Modeling will be automated at some point. What will not be automated is the ability to collect and amass and clean good data, not just big data. So if you have ambitions to start a startup, to have a startup that's focused on data, try and innovate systems that allow you to serve your customers high quality data at scale. If you know how to clean satellite data, that's a very good market to be in. If you know how to produce data sets for machine learning, for deep learning, for object detection, like what I showed in the slide before, That's very good. There's a lot of money to be made by people that just produce data. And I say this because high quality data is the main bottleneck. Generative AI, things like ChatGPT, will automate a lot of decision support tools. And so will mechanistic crop models. Essentially, if you're an agronomist, there will be a day that you will do your agronomy from a laptop. But what will never change is whatever decisions you're making will have to be based on good data, which means somebody has to produce good, clean data and give it to you to make a decision. And it is that person who will remain in business when everything else is automated. So, when you look at the typical data science projects, you will start everything I've talked about. If you wanted to start, you start with data. On this slide, you start with the box that says number 1 on it. You need to have good data, and you will need to have a clear picture of getting to an end user so that the end user can make a decision of yes or no on something. So these are the 2 things you need, first of all. Some end use case for whatever data you want to get into, and a source of data that supports that use case. If you have these 2 together, number 1, then you need some skills to clean your data, some skills to produce some models from your data that answer the questions that your end use case requires. So maybe you need some Python programming skills, and you need some R statistical analysis skills in order to complement your ability to collect the data. And this is where most people want to join data science. They want to join at number 2, not number 1. They want to learn R, learn Python, and then they learn these things, and then they realize, I don't have any data to analyze. It's because you're thinking about number 2 before number 1. You need to know the problem that you want to solve, and then you gain the Python skills and the R skills that allow you to solve that problem. And maybe you can gain the Postgres skills. That elephant on top is Postgres database management, database administration skills, because you have to keep your data somewhere. You can't keep your data in R or in Python. You keep your data in a database and call it from R. And then you use all these web services and produce dashboards or applications or websites, or link everything you've produced to ChatGPT so that it can answer questions for people, and then it can go to the farmer. But everything starts with number 1. Collect data, good data, clean it up to answer a specific question that your farmers, your customers want. And that is what everybody should focus on. So for those who are just getting started on their data science journey, first of all, learn the sources of good data, learn data structures, how data looks, how you can clean it, how you can bring it together to make decisions. If you can do that, you can form a whole startup based on that. So this is what this slide is meant to communicate. There'll be a lot of technologies, very confusing. That's why I left all those logos there. But you will notice almost on every one of them, I've placed the ChatGPT logo. And the reason why I've placed it there is because all of those things will be automated at some point. At some point, GPT-4 will take instructions from an API and download all satellite data into your programming environment. GPT-4 is already capable of doing that. You just have to develop the plugin. GPT-4 will load data into your database and take it out of there. It will do that with natural language. It is something that's coming, whether you like it or not. But what GPT and all this fancy tech will not do is understand your problem and how it should format the data for you to model and answer that question. It is always you who will understand a problem and say that with the data that I have, this is the transformation I need to make for this data to make sense and answer this question appropriately. So if you equip yourself with data science, data engineering skills, you will be fine. That's the take-home message from this. Without taking much time, we started a little late, but we're still 11 minutes. Well, I've shared some free data sources here. There is Amazon Web Services Registry of Open Data. You'll find lots of data there. There is Google Earth Engine. There is NASA Power. Please go to NASA Power. If you have to go anywhere today, to any website, go to NASA Power and just see the data that is there. You'll be mind blown. There's the European Space Agency where you can get satellite data. The CGIAR has a website, FAO has a website, and so does SOIL. My final slide is to ask everybody to just implement your dreams. There will be a lot of naysayers, especially people that say data science is a fad, it's a hype, it will die. Farmers can't afford smartphones, even if you produce smartphone-based products. Remember in 1950, people were saying we can't afford electricity. Today we do. In 1995, we couldn't afford TV or DSTV or GoTV. Today people do. There was a time then everybody was saying Africans can't afford cell phones. Today they're everywhere. We are even leading in e-commerce on cell phones with M-Pesa in Kenya. We were not supposed to afford the internet and smartphones. So yet here we are having a webinar. So anybody who says these things can't be done is because they are not an innovator and they are not looking at the bigger picture, the future. If you always build for today, you will never innovate. So innovation starts from visualizing what other people don't. If you have an application that will only need a smartphone and people don't afford smartphones, the few that have smartphones will be your market. Don't always aim at pleasing every single person. You don't have to produce a solution for 200 million Nigerians. Whichever market segment you can reach with your ambitions to start data science startups, do it. Naysayers will never stop. Even if we afford all the smartphones, they'll tell us we can't access apps and understand them because most people are illiterate. There'll always be a naysayer. Just do what you have to do in order to pursue your passion, if your passion is data science. And with this slide, I will take a lot of questions, I know, but thank you so much for paying attention to me. Thank you.
Awesome, 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 awesome. I am so excited. This is very, very loaded. I don't know about you guys, but I've just been typing and typing those point lines, those insights, those foresights, from Dr. Joseph. Man. So he ended with this. There are going to be naysayers, but do not listen to them on your way to actually achieving your dreams. And he's actually talking to me. So yeah, there will always be those who would say, and the example you used about internet, about smartphones, people tend to tell me now, drones are expensive. Oh, they will not be able to fly in Africa and all that. Like, I just refer them to smartphone. Do you remember 20 years ago? How much was the smartphone with you? That's just my, and that solves everything for them, because that is the future. And we know that things are going to change. Thanks so much for joining, guys. Thanks again for your insight. Yeah. And this is what Senok is saying. Thank you so very much. Thank you so very much. So guys, it's now time for questions and answer. So I have some questions already in the comment section. I will just do well to find them out. But if you have questions, guys, pop it in the comment section. I'm going to be highlighting them so that we can deal with them. All right, all right, all right. So somebody asked, these are what is the impact or the effect of electrical conductivity on crop production? You're a soil scientist, so please shoot us that. Because I remember you were mentioning about data around that. Yeah.
All right. Yeah. So electrical conductivity, the conductivity itself um, is not a problem in the soil. We are using conductivity to understand something else. We know that conductivity of soil and conductivity of water and conductivity of saline water that contains salt, will be very different. So if you have a very saline soil, it's going to have very different levels of conductivity compared to an okay soil. If you also have a soil that has high volumetric water content, it's also going to have very different conductivity to a very dry soil. So you use electrical conductivity as a measure of variation in your field, not as an indicator that will affect your plants in any way. If you have a water problem in your field and you want to understand, some parts of my field seem to have clay soil and they hold a lot of water. Some parts of my field are very sandy, they let go of a lot of water. But I want to understand where this exactly occurs so that I can irrigate differently. I can practice precision irrigation. The way you're going to be able to know uh, how to lay out your precision irrigation map is using electrical conductivity, because it's going to show you high conductivity in some areas and low conductivity in some. And using that, you make a decision. So that's the use of electrical conductivity.
Also, thank you so much for that concise answer. I want to highlight this. Arad is actually a friend, also from Malawi.
Okay.
Yeah, he said amazing work with the website. Apologies, I didn't call it rightly with the mother's tongue.
It's okay. I expect
Yeah,
that.
I don't want to mother it again. Okay, so I'm just looking around for questions. I can see comments. Yeah.
I got one
Now,
that I
now,
really liked for me. Somebody asked what mechanistic crop models.
yes. I'll see coming there.
Okay.
Okay, let me quickly highlight that. Okay, just a minute. Yes, and that is it. Actually, that's me.
It is the flying farmer.
But I was
Okay.
because that sounds like a big grammar. But
Yeah.
so I just put it there so that you can actually attend to
All
it.
right.
Yeah, so make it
It's
simple.
it's a very mechanistic, very big word, but it's not that complicated. The models are meant to be representations of the world, and
Mm,
there are two ways to represent the world. You either represent the world from data, so you just collect data and build a linear regression model that says nitrogen, as nitrogen increases, my yield increases, and you build a regression line. That is an empirical model. You are producing a model of the world based on your observations. That's why it's called empirical. You take observations, and the observations tell you how the world behaves. Mechanistic models, they are conceptual. They are based on your understanding on how the world behaves. Your, and
mm,
not your observation, but your knowledge. So if you know that, an example of a good mechanistic crop model is, uh, we know that population increases exponentially in a country. So we have learned that since maybe primary school, that population grows exponentially.
yeah.
And using that, if I tell you the population of Malawi today, and I ask you what will the population of Malawi be in 2050, you can use what I've told you today and just slap an exponential growth equation on it and say by 2050, because population grows exponentially, it's going to be Y. So that is a mechanistic crop model. So in agriculture, mechanistic crop models are things like, how does fertilizer affect crops? We all, if you have an agricultural background, you know that your agriculture teacher will have told you, as you increase fertilizer, the crop yield will increase until you reach a certain toxicity level, and then it flattens off. That is mechanistic thinking, your understanding of how the crop grows. Yeah, so that's what a mechanistic crop model is. So if you hear anybody saying I'm a crop modeler, mostly they're talking of mechanistic crop models, things like DSAT, APSIM, all these crop models that are becoming famous. Most of them are based on mechanistic understanding. Yeah.
All right. So I have, okay, I'm going to attend to this question. Can we have the slides and go through the interesting tips? You do not need to have the slide. This webinar you can replay it over and over again on this channel. And I want to employ every one of you on this channel to subscribe to this channel so that you can be able to, we're coming up with a lot of content so that you don't miss webinars. And yeah, so you can even watch a lot of it that we have, like 4 or 5 previously on this channel. So thank you very much. I have another question. Yeah, good, from Stegon. Okay, Dr. Joseph, you can see the question. Say Africa is still the dark continent when it comes to data. The primary data missing are consumer taste, preference, reading, propensity to spend, purchasing power. How do we go about this? I think this is tilting to away from production into economics.
Yes, but yeah, thank you so much. I don't know how to pronounce that name. Is it Segond or something like that? That is a very thought-provoking question, and it's one of my big questions. The things you have written there are the determinants of what people should grow and where. You should grow crops that people have taste for, have preferences for, things like that, where there is purchasing power for those things. Socioeconomic data is very hard to collect. The only way that I think is practical is to crowdsource that data with incentive. So if you have a system that has an incentive for you to submit data and accurate data, you may submit fake data, but if you have enough people submitting there, you have a data scientist that will clean the data, you can have a way of getting people to submit. For example, just thinking hypothetically, something that I've been thinking about. There's a problem with knowing market price. We don't know how prices are moving for goods. What is the price of cassava in so market and so market and so market, and how is it evolving over time? Nobody has the incentive to submit that data anywhere. But if you had a system that shows market price for cassava everywhere, many people will want to use it. But if for them to use it, they have to submit the market price for cassava in the area where they live. Before they access the data, they will submit, and you will collect data that way. So having systems that incentivize data submission are important. It is essentially what ChatGPT is doing to us. They've given us a version of ChatGPT-3 based on GPT-3. We are using it because the incentive is we are wowed. Oh, wow. And we're asking questions and we're doing everything we are submitting there is being kept. It's more data for the model and it will improve. The incentive is how awesome it is for us. So I think if we have such systems, if we incentivize data submission and then make that data available so that we can crowdsource, I think that is the way to go about it. Otherwise, we'll keep doing surveys, and I don't think we'll get very far, to be honest. Yeah.
All right. Thank you so much. I have this question here, which I see interesting. Yeah. Which is better to learn, data analysis or data science skills for digital farming?
That's a tricky question, but data analysis is part of data science. What you need to learn is this thing. Everywhere you go, every time you Google, if you take your cell phone and Google and say, how do data scientists spend most of their time? As a data scientist myself, I will tell you these days I spend 90% of my time cleaning data in the context of the problem that I am analyzing. Data preparation, which is essentially data science. The analysis part, once I have understood the problem and I have prepared my data in such a way that it speaks to the problem, the analysis part, the machine learning part, the fitting the model part, while it is the hardest thing to learn, it is the easiest thing to do once you know how to do it.
Hmm.
Because the models are there, you just have to fine tune them with hyperparameters and all of that. What is important is to have the right data to feed those models. And that is a science skill that combines your subject knowledge expertise and your statistical analysis expertise. There's this term called extract, transform, load. Your ability to extract data from different sources, transform it into usable format, and load it to whatever system you're loading it to. That is the most valuable skill that you can learn. So it is part of data science, but I've expounded to separate it from data analysis, because analysis is tell me the results of this using X model, and that's an easy thing. Anybody can do that.
All right. So we right about now we are coming to the end of this webinar, and we want to say thank you to Dr. Joseph Mhango. This has been an amazing section. Thanks to our partners, Integrated Acquisition, Tag NG, and White Up Global. So I would end with this, as usual. The best way to predict the future is to start creating it. So Dr. Joseph has actually told us today, say no to naysayers, respond to them by their notes, and forge ahead, because data is transforming agriculture. But the question is, how are you going to be using data? Data is everywhere. How are you going to collect this data, process this data, and answer questions, solve problems with data? So go ahead and begin to explore. So you can actually watch this webinar again and again. Thank you so much, Dr. Joseph. We are honored to have you, and we hope that when we call on you the next time, you can be able to share more with us on this journey. Thank you so much,
Thank you.
guys.
Thank you very much. Thank you.
Bye. Bye for
Bye.
now. Yeah.